Hello everybody, welcome to this channel. I'm Payman Nasari. In this tutorial, I'm going to talk about how to build a random forest classifier using RapidMiner. The process includes get the data, then we need to pre-process the data, after pre-processing, then we need to build a model. It is modeling. And next is to calculate the performance of the model. And after calculating the performance, we're going to give you some insight and some tips on how to improve the performance of the model. So let's get started. The first step is to get the data. The data set that I have is about iris data, which can be found on the internet, and I will put a link in the description. But I saved the data in learning repository, and it is in the data folder. It is called iris data. Simply, I grab it and bring it to the panel, and I want to take a look at the data first. So I need to connect it to the output and run it. The dataset that I have has 150 examples with 5 regular attributes, and these are the attributes. And the class in our case is the target variable, and we have the width and length of petal and sepal of the 115 different flowers. We can take a look at statistics as well. As you can see, these are the different features that we have, and this is the class or our target variable. All the data set that we have are real, and there is no missing value. And we can take a look at the class distribution as well. And if I just open the visualization, we see that we have 3 different classes, Setosa, Versicolor, and Virginica, and all of them have the same amount of flowers. The second step in order to build a model is to pre-process the data. Pre-processing the data includes handling the missing values, taking care of outliers, transforming categorical variables, and other stuff that you have to do in order to make sure the data is as clean as possible. The higher quality data you have, a better model you can expect to build. In our case, we don't have missing values, we don't have outlier, and the data is already cleaned. What we're going to do is to tell RapidMiner what is our target variable and then split the data. In order to specify the target variable, we use an operator called setRole. SetRole, we bring it here, connect 2 operators together, and I need to configure this operator, setRole. And what I'm going to do is actually to specify the attribute name. In our case is the class, and the target role is label. That is how we configure the set role. Next is to split the data into training set and the test set. And in order to do that, we use a split data operator. Bring the split data operator into the process panel, connect these 2 together, and configure this operator. In the partition, we use edit enumeration, and we add entry. The first entry is the proportion of the data that goes to the training set. And in this case, I'm going to use 70% of the data for training. And I add another entry for the test data, and what is left, we use for test, which is 30%. Okay. And I need to choose the sampling type. There are different ways we can sample the data: linear sampling, shuffled, stratified, or automatic. Here I'm going to use stratified as well. Also, I use the local random set, and I choose this one to be only 1. After splitting the data into training set and the test set, we're going to build a model. And in this case, I'm going to build random forest. I call the random forest operator. Random forest operator, bring it into process panel and connect this two operators together. And I need to configure the random forest. The first is to choose the number of trees that we want to use for random forest. This can be any number that you want. I choose 100. The next is criterion. There are different criterion that we can use: Gini ratio, information gain, Gini index, accuracy in the case of classification. And if it is random forest regression, then you can use least square. In this case, I'm going to use Gini index. Also, I need to choose the maximal depth. This, I can choose any number. The smaller it is, the smaller the random forest would be. I choose 5, and I don't want to apply any pruning or any pre-pruning. And that is the configurations that I choose for random forest. Now our model is built, and I'm going to calculate the performance of the model on both training set and the test set. And because I need to apply the random forest on both training set and the test set, I need to make a copy of the model. And in order to make a copy of the model, I use multiply. Bring the multiply operator here and connect the model to this one. What it does, actually make a copy of this random forest model. And next, I'm going to apply model to the data on training set and the test set. So in order to do that, I call apply model. Bring the apply model operator here. And I get the model from here and get the training data from the random forest operator. Connect these two together. And I rename this one as apply model training. Next, I need to calculate the performance. And in order to calculate the performance, I call the performance operator for classification. Bring the operator here. Connect these two together. And I need to configure this one. There are different parameters that we can configure. The first one is the main criterion. There are different metrics that you can choose. I choose the first, and the first metric that I choose is the accuracy. There are a lot of different other metrics that we can choose based on the problem that we have. Here, I'm going to choose accuracy because that is what I am going to use for measuring the performance of the model. And I rename this one as performance on training. So this will give me the performance of the model on the training set. So I need to connect this one to the output. And I need to run the process. And this is the results that I get. And I have 100% accuracy on the training set. Let's go back to the process again and calculate the performance on the test data as well. So basically, I need to bring the apply model and performance and configure it for test data. So I need apply model. And let's first rename it. This is for test data. And I need to get the model first. I bring the model from this multiply. And because this is for the test data, I need to bring the test data from a split operator. And I need to calculate the performance. I bring the performance operator for classification. Remember that apply model has nothing to configure. And I connect these two together, rename this one, performance for test, and I connect this one to the output. And if I run the process again, I get two performance, one for the training that I have 100% accuracy and one for the test that I have 95% accuracy. Let's take a look at the results. On the training set, we get 100% accuracy. And as you can see from the confusion matrix, there is no misclassification. All of the classes has been classified correctly. But if we take a look at the test data, we get almost 96% accuracy, and we have some misclassification, as you can see here. This is an indication of high variance in the model that we have. There are different techniques that we can reduce the high variance. First of all, we can pre-process the data and make sure the data is as clean as possible. And the other way to reduce the high variance of the model is to use the different proportion of the data for training set and the test set. Here we use 70%, 30%, but it is possible to use 80-20, 90-10, or 95, even 5. Or we can change the parameters of the random forest. The number of the trees that we use in the random forest can be changed. The criterion we can change and see how it will improve the performance, the maximal depths. And in order to reduce the high variance, we can definitely apply pruning and apply pre-pruning on the model that we have. These are some techniques that we can use in order to reduce the high variance of the model.